Hello, my name's Mark Roberts. I'm a solution architect at Red Hat, and in this short video, I'm going to take you through Red Hat OpenShift Service Mesh. Now, we're in the topology view of OpenShift right now, and we're looking at a microservice-based application. It has 7 parts to it. As you can see here, we have 7 individual pods running, each of which contains a container image for a part of the application. Now, at the moment, there's nothing to indicate on this screen right here which component is calling which other components. Additionally, there are no routes shown on here either. There are no little triangles shown in the sort of top right corner of any of those applications on there to indicate how we're going to actually interact with the application. The communication within this application and the ingress into the application, into the cluster, is being handled for us by the service mesh. Now, the service mesh has a number of moving parts. There is a control plane and there is a data plane. And within part of that, we have a sidecar which is injected into each of the nodes. So when an application is configured to take part within the service mesh, we create new deployments as we would normally, but we get an additional component added to them. And let me show you one of those now. So let's just pick on one of these nodes. Here we can see for this particular deployment, we have one pod. In fact, if we look at one of the others, I think some of them have got 2 pods. Let's try another one. There we go. So this one has got 2 pods running for this particular deployment. So we're doing a bit of load balancing within that. And if we look at one of these pods individually and scroll down looking at the details, in the containers section here, we see layer 2, which is my application that I'm running to deliver the functionality that I want. But I also have an additional container within that pod called the Istio proxy. And that's the sidecar that is taking control of all of the communication that takes place within this particular pod. Now, if we go back to the topology view, what we can see in the top corner here is that we have a link through to something called Kiali. Now, Kiali is used for visualization of what is happening within the service mesh. And the best way to show you some of the YAML definition that is behind this is to actually go across to Kiali. So let's leap across into there, it loads up the Kiali user interface, and we get a very similar sort of pattern fly user interface that we've seen previously in OpenShift. And if we look at the Istio config here on the left-hand side, we can see a number of the custom resources that have been created to operate this particular service mesh. The first of those is the gateway. So let's have a look at that. So we have a gateway listed here for this particular application. This is the ingress gateway, and we are using the ingress of the Istio control plane. There is a pod running within there. In fact, let me show you that. Let me just duplicate this window. And if I go to a different project, if I go to Istio system and have a look in here at the pods that are running, you will see in here that we have a pod running called Istio Ingress Gateway. And that pod is running the Envoy proxy for the service mesh. And it is that is the entry point into the application for us. So back to Kiali. So we are using that, picking it up by a label, just using a selector as normal. So the has an Istio Ingress Gateway label attached to that pod that we just looked at. And it will route traffic that comes in through to port 80. So it's listening on port 80 on HTTP. Go back to the Istio config. We can see here that we have a number of different layers defined. If we have a look at the virtual service for this one here at the bottom, then this one here is showing that we are trying to match particular URLs. And when we do that, we are going to route across to a destination host called layer 1. Now this layer 1 at the bottom here in line 45, that is a plain old ordinary OpenShift service that we have defined within the project. And in fact, if I go and look at the services that are defined within here, we will find that. So we have networking and services. There it is at the top, layer 1. So it's just a plain old ordinary service. But the service mesh, the virtual service here, is managing that routing for us. Now we're trying to match on some URLs, and we're exactly matching on the URL called core layers, exact match on get info, and an exact match on the route as well. So when we call out to those URLs, they will be routed forward into here, into layer 1. We also have defined within here some destination rules. And the destination rules allow us to distribute the traffic between version 1 and version 2 within here. And if we look at the associated virtual service that goes with that, so we look at the layer 2 virtual service, we'll see the weighting that we want to happen in there. So we want a weighting of 80% going to the host identified as layer 2 subset version 1, 20% is going to layer 2 subset version 2. So that will direct the traffic in an 80-20 split. So let's have a look at that operating now. If we go back to our graph, we can see that currently it's empty because we're not showing any of the nodes. So over here on this display menu, I can choose what I want to display. So I can look at idle nodes and it will show me all of the nodes that are defined. And if we switch on traffic animation, when we start throwing some workload into it in a second, we'll see it come to life. So let's do that. A really simple application that I can just throw some workload in, and you can see on screen there we're hitting layer 1, then across to layer 2, then across to layer 3. Now we have multiple versions of layer 2, and we have multiple versions of layer 3. We have multiple pods for some of those versions in layer 2 as well, as you saw. So the graph is now starting to appear. We can see the Istio ingress gateway on the left-hand side there. That's the entry point into this application. And we have got the traffic animation turned on. So it's showing us some little blobs flowing across the diagram. If we also turn on that we wish to see request distribution, we can then start to see the percentage distributions of the traffic. And it takes a little bit of time to settle down. At the moment, we've got 87.5% going to version 1, 83% now to 17%. So it's getting us towards that 80-20 split that we were aiming for that distribution. Now, we're seeing quite a lot of data coming across now on here. If we click on one of these routes, then we can see a little bit more detail about what's going on. And on the right-hand side here, we have this great section called traces. This allows us to look at a particular span across there to see exactly where the traffic is going. And this focused on these two paths here going from layer 2. We can see that we have that sort of purpley color highlight in there, showing us that track of how that data has progressed across. If we want to see a full trace, then we can show that in tracing. And if we look through into here, I just need to log into this with my OpenShift credentials. And we can see in here that we now have the ability to look at the detailed tracing and timing operation that took place between those individual components. So if we highlight on this one here on the green, we can see how long it ran for. So it only ran for 2.03 milliseconds. And if we look at this one here, the layer 3, we can see that that had a duration of 1.21 milliseconds and a start time of 313 microseconds. So the delay that you can see there on the left between the green one starting and the sort of orangey yellow color starting as we hit the layer 3 is 313 microseconds. So we've got staggering accuracy there of information. Obviously, if you see delays of timings that you're not happy with, you can focus in on those and start to understand why a particular delay is occurring in the communication chain taking place through an application. So the Kiali visualization is great in terms of showing us what happens within our applications. We have a little bit more YAML that we have to create in terms of the definitions of the gateway, the virtual service and the destination rules that work together to provide that distribution of traffic between the different versions that we have. We can also incorporate into here mutual TLS between these different services. We can bring in a circuit breaker function that can lift off the traffic and allow a service time to calm down and recover if something gets overloaded. And we have throttling that we can do as well to control the throughput of data using service mesh. So I hope that's been useful as an introduction to Red Hat OpenShift Service Mesh.